Ever wondered why things move the way they do? Why a bouncing ball comes back up, or why you feel a push when you push against a wall? Well, there's a secret hidden in the laws of physics, a principle so fundamental it's like a guiding light in the dark. It's called Newton's third law of motion. The first and second law is discussed before. Make sure to check that video. In the big picture of physics, there's a super important idea that helps us understand how forces work in the universe. It's called Newton's third law of motion. This law says that for every action, there's an equal and opposite reaction. If an object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. Newton wrote about this law in his famous book, the Principia Mathematica. It changed how we see motion and force. Let's explore this idea and see how it shapes the way things move. This law signifies a particular symmetry in nature. Forces always occur in pairs, and one body cannot exert a force on another without experiencing a force itself. In the next few sections, let us learn Newton's third law in detail. Force is a push or pull acting on an object resulting in its interaction with another object. Force is a result of an interaction. Force can be classified into two categories: contact force such as frictional force and non-contact force such as gravitational force. According to Newton, when two bodies interact, they exert force on each other, and these forces are known as action and reaction pairs, which is explained in Newton's third law of motion. When one body exerts a force on the other body, the first body experiences a force which is equal in magnitude in the opposite direction of the force which is exerted. The mathematical representation of Newton's third law of motion is let A be the body exerting force. F equals minus F. Newton's third law of motion is associated with conservation of momentum. According to the law, for every action, there must be an equal and opposite reaction. A variety of action-reaction pairs are evident in nature. We have listed a few below, and they are as follows. Propulsion of fish through water is an example of an action-reaction pair. A fish makes use of its fins to push water backwards. This push serves to accelerate the fish forwards. The size of the force on the water equals the size of the force on the fish. The direction of the force on the water, backwards, is opposite the direction of the force on the fish, forwards. The flight of the bird is an example of an action-reaction pair. The wings of the bird push the air downwards. The air pushes the air upwards. A swimmer pushes against the water, while the water pushes back on the swimmer. Lift is created by helicopters by pushing the air down, thereby creating an upward reaction force. Rock climbers pull their vertical rope downwards to push themselves upwards. That's it for today. Make sure to like, share and subscribe.